Picture this: our Sun, in its fiery youth, blasting out colossal waves of superheated plasma that could have dramatically altered the cradle of life on Earth. It's a thrilling glimpse into the past that might just rewrite how we view our planet's history and our future. But here's where it gets controversial. Could these ancient solar tantrums have been the secret architects of life itself, or were they more like destructive bullies eroding our world's early atmosphere? Stick around, because this discovery from a star much like a younger version of our Sun is about to blow your mind. Our Sun is no stranger to dramatic outbursts, regularly hurling immense clouds of plasma. Think of it as a supercharged gas made of charged particles, into the vast emptiness of space. We call these events coronal mass ejections, or CMEs for short, and they're often paired with sudden, intense brightenings known as solar flares. Sometimes these plasma storms stretch far enough to rattle Earth's magnetic shield, sparking mesmerizing auroras in the night sky, triggering geomagnetic storms, or even knocking out power grids and causing widespread blackouts. For beginners, think of Earth's magnetosphere as a protective bubble. When CMEs punch through, it's like a cosmic game of pinball that can light up the poles or disrupt satellites and electricity. Scientists speculate that billions of years ago, when the Sun and our planet were just getting started, the Sun was far more tempestuous. Back then, these CMEs might have played a pivotal role in shaping life on Earth, influencing everything from the atmosphere's composition to the evolution of early organisms. Past research has shown that young stars similar to our Sun in its prime, acting as cosmic stand-ins for that era, often unleash flares that dwarf the biggest ones we've seen from the modern Sun. These flares are like massive energy explosions, releasing radiation and particles at unprecedented levels. The massive CMEs from that ancient Sun could have had profound effects on the young environments of Earth, Mars, and Venus, potentially stripping away atmospheres or altering their chemistry in ways that either nurtured or hindered life. Yet a big question lingers: just how much do these explosions on young stars mirror the solar CMEs of our Sun's wild youth? In recent years, we've spotted the cooler parts of these plasma ejections through ground-based optical telescopes. But the speedy, high-velocity components and the sheer frequency of powerful CMEs from the past have remained hidden, like elusive ghosts in the data. To crack this mystery, a global team of scientists, led by Kosuke Namakata from Kyoto University, decided to investigate whether young Sun-like stars produce CMEs akin to our Sun's. Their groundbreaking work, published in Nature Astronomy, shines a light on this enigma. What drew us in was the enduring riddle of how the young Sun's ferocious behavior shaped the budding Earth, Namakata explains. By teaming up with observatories in Japan, Korea, and the United States, we pieced together a snapshot of events from billions of years ago in our solar system. The team's approach was a masterful blend of technology. They combined ultraviolet snapshots from the Hubble Space Telescope with optical data from ground-based telescopes in Japan and Korea. Their focus was on a youthful solar twin named Ek Draconis, a star that's like looking into a mirror of our Sun's adolescence. Hubble zeroed in on far ultraviolet light lines that reveal scorching hot plasma, while the trio of ground telescopes tracked the hydrogen H-alpha line, which follows cooler gases. This multi-wavelength, simultaneous observation was key. It let them catch both the blazing hot and the milder cool elements of the ejection as it happened in real time. And this is the part most people miss. These observations uncovered the first solid proof of a multi-temperature coronal mass ejection from Ek Draconis. They detected ultra-hot plasma sizzling at about 100,000 Kelvin, blasting out at speeds of 300 to 550 km per second, trailed roughly 10 minutes later by cooler gas around 10,000 Kelvin moving at a more leisurely 70 km per second. The hot plasma packed a much bigger energetic punch, hinting that back in the day, frequent superstrong CMEs could have unleashed powerful shocks and high-energy particles, potentially scouring or transforming the atmospheres of early planets. This ties into broader theories and experiments that highlight how such intense CMEs and their particle showers might have jump-started essential biomolecules and greenhouse gases, key ingredients for life to take root and thrive on a nascent world. In simpler terms, imagine these solar storms as cosmic chefs, whipping up the right conditions for life, or perhaps as harsh editors, pruning away unsuitable environments. Either way, this finding carries huge weight for grasping how planets become habitable and under what circumstances life can emerge, not just on Earth but possibly on distant worlds too. What made this study a triumph was the seamless international collaboration and the precise synchronization of space and ground-based tools. It was gratifying to see that, despite our diverse backgrounds, we all pursue the same noble quest for scientific truth, Namakata notes. And here's a controversial twist. Some might argue this paints the young sun as a benevolent force fostering life, while others see it as a destructive one that could have delayed evolution, or even rendered planets barren. Could these findings mean we underestimate the role of stellar violence in shaping worlds? Or might it inspire new ways to protect Earth from future solar flares? For more details, check out the full paper, Discovery of Multi-Temperature Coronal Mass Ejection Signatures from a Young Solar Analog in Nature Astronomy, 2025, DOI 10.1038/S4150-025-02691-8. What do you think? Does this change how you view the sun's influence on life? Could ancient solar activity have been a blessing in disguise, or a curse? Do you believe studying stars like EK Draconis will help us better prepare for space weather threats today? Share your opinions, agreements, or disagreements in the comments below. Let's discuss.